Hey everyone, for this video what we're going to do is kind of take a look and discuss this interesting problem based upon the knowledge that you know really coming out of Programming 1. I had asked in the instructions for you to actually look at this problem and do your own assessment on it and analyzing of it and possibly designing it all the way to programming it. Doing so, like I said, will really help you in your understanding of what we're going to be talking about this week. If you haven't done that yet, please stop this video and go back and do so. Spend some time looking at this problem and thinking it through on your own and how you would approach it. All right? With that said, we'll go ahead and start talking about this now in regards to how I would approach it and see if we're on the same path. Okay? This problem, an interesting problem, I don't know why I called it that, something stupid, I guess, was is one that I think it's a real simplistic. That's why I think it's actually interesting. But it's interesting, it's also not overly simplistic. It actually can get really, do you want to say, long, possibly, based upon what our knowledge is at this point in time. So, for the most part, what this thing is asking us to do is developing an application, right? That's just going to take classroom and cookies sold in, okay? The student's going to bring in a slip or a receipt or a form, whatever you want to call it, that would have the customer name, the number of boxes sold to them. Again, we didn't really care about what type of cookies. I guess we just sold one type of cookie, whatever you wanted to make it, but you don't need to do that. Student name and the classroom. The teacher will then collect all these receipts, slips, or whatever from each student in each classroom and take them to the office where the administrator's at. And we'll just say, let's just kind of pretend she dumps them in a box. And so at the, when this thing was all over with, the administrator had a box full of hundreds, maybe thousands of slips representing every order that every child had sold from every classroom. The goal here was the administrator wanted a very quick and easy way to being able to tally all of this, determine at any point in time as she's entering um, who's winning, and in the end, who actually won, what classroom sold the most cookies. So they would receive the incentive of an outing at some point in the year. Does that make sense? So yeah, we could possibly take this further if we wanted to, but for sake of example, that's all this is actually asking us to do. All right, so pretty simple all the way through. All right, so they would enter she would pick up a slip, enter the classroom, enter the cookie sold, press submit. Pick up the slip, enter the classroom, enter the cookie sold, press submit. Pick up the slip and keep doing that. Very monotonous, I agree, but that's how this is going to actually work. Okay, so our job was writing this for them. How could we possibly do this? Okay. And so when I sit back and again, I call it an interesting problem, I call it an interesting problem because I think it is simplistic, yet it does tend to be tedious in nature. So how would I do this? Well, there's two pieces to this piece, right? That one, collections of the cookies and putting them in the right buckets representing each classroom. And then two, comparing all these buckets, if you will, aka variables, to determine who has sold the most. So how would we do this? Well, based upon our simplistic knowledge of conditional programming, this is pretty much what I would do. I would collect my cookies in classroom. My output's going to be winning number of cookies and winning classroom, but the first thing is to put them in the buckets. What do I need to do? Well, I need to compare the input and say, is this classroom 1? I would put it in classroom 1 cookies. Is it classroom 2? I would put in classroom 2 cookies. And I probably should call those classroom 1 cookies sold, classroom 2 cookies sold, all the way down. I would do that for up to 10 classrooms for this particular situation, okay? I stopped at 5 just so it would not get monotonous for you and for me, okay? So in a case, I would basically have this nested if all the way through doing this, correct? Was yours very similar? I would think it would be. And then then to get it out. So if I press that statistics button at any point in time, I need to figure out who's winning or who's won. How I did this is how I designed this is I created a couple of variables called winning cookies and winning classroom. And I kind of preset these to classroom 1 cookies and classroom 1. And then I started comparing by not a nested if, but a bunch of if statements, but if different structures, asking the questions: is cookies 2 greater than cookies greater than cookies, whatever was there before, in this case, cookies 1. If it is, I set the winning cookies to classroom 2. Then I go to the next one. Was classroom 2 greater than whoever's winning? And classroom 4, and so on. So I replaced it based upon if any classroom was greater than another classroom. If you kind of look at that logic, it's kind of a neat way of doing that versus some big, long compound condition that I know some of you like to write. Stay away from compound conditions. This eliminates the need for something like that. And once again, I would do that all the way through 10 classrooms. I stopped there at 5. When I'm finally done, in this case, I would display how many cookies were sold and who the winning classroom is, okay, in that regard. Does that make sense? Once again, in your design, was that pretty similar? I would hope it'd be close, if not right on, okay? Again, this problem wasn't here to trick you. This problem wasn't here to utilize what we have learned over the past couple weeks in regards to looping and string manipulation. It was basically here to just kind of demonstrate how would you write this based on your knowledge coming out of Programming 1. Okay? All right, so what do you think about this? Not too hard, but tedious, don't you think? A lot of code, a lot of repetition, a lot of repetitive code over and over again. And of course, when you see repetitive code over and over again, what's your thoughts? Well, now that you are in Programming 2 and you have spent a few weeks doing loops, you probably should be thinking about a loop. However, how can we be doing a loop if we're comparing different variables? All of a sudden things don't work because we're constantly dealing with different variables, right? So if we sit back and we had to write this program, how many lines of code would something like this take? Well, if we sit back and we look at it and we say, okay, we got to declare all the variables, so I at least need a variable for every classroom and probably variables for so that's our biggest one, right? If I had 10 classrooms, I need 10 variables for each classroom, or to represent all the classrooms, I should say. 10 variables to represent all the classrooms. Then I would need a couple variables for my outputs. Not that big a deal. So 10 dim statements, 12 dim statements, whatever it is, right? And then we would need about 3 lines of code based upon my design and determine the classroom and add to the total. So that was what I had up here. And I'm roughly around 3 lines of code, if to the else, and so on, a bunch of end ifs. So probably about 4 lines of code per I could say. So approximately 3 lines, 4 lines, whatever, to do something like this. And I would do that for every classroom. So in this case, we'll just keep it on the low end, 3 lines of code times 10, 30 lines of code to handle 10 classrooms. Kind of forgot about the end if, so probably we're up to 40. And then for the output, we would need about 4 lines of code to determine the winner. That's what I had here, approximately, plus a couple extra lines here and there, correct? And so once again, if we start adding all this up, my variables, I would at least need 10 lines for my variables if I had 10 classrooms, probably a few more. 30 lines to add totals, once again, probably a few more. And 40 lines of code to determine the winner at a minimum, but probably again a few more. So approximately at a minimum, this program is going to take us about 80 lines of code. No big deal. 80 lines of code goes fast. You probably could cut and paste, and life is probably pretty good. What happens when they come back to us and they say, I want, we have 20 classrooms now. We had 10 this past year. That was great. Next year, we're going to have 20. A lot of people are going to participate. More classrooms are going to participate. We have to come back in and literally just double our code, correct? We would have to add twice as many variables. We have to represent up to classroom 20. And then again, the conditional, I should say, if I can say it, the conditional logic to get the data in and get the data out, correct? And so next thing you know, we're up to approximately at a minimum 160 lines of code. Very repetitive, very redundant type code. How about 50? How about 100? What happens now? Now all of a sudden we're up to 400 lines, 800 lines, doing simplistic task of just putting things into buckets and then comparing those buckets. Ugh. So you guys haven't really come across anything like this yet, but it happens all the time in programming. So is there an easier way? Well, I wouldn't be talking about this if there wasn't. If I could sit back and tell you I could reduce these lines of code okay, getting the inputs. Uh, if I could, let's go back here. If I could sit back and say, no matter how many classrooms I have, I will just declare one thing and one thing only. So if I have 100 classrooms, I wouldn't have a 100 dim statements. I would have one. Would that interest you? If I sat back and said I could take all this code here in regards to putting it into the correct buckets, and I did so, it's, in this case, it was about 40 lines of code. We said with 10 and 80 and so on. If I can reduce that down, no matter how many classrooms are in the school, to one line of code, would that interest you? If I sat back and I said, okay, to get the information out, and again, for 10, we're looking at about 40 lines of code here, and for 20, 80 lines, and for 50, what do we say? I don't know. 50 be 200 lines and so on. But I can reduce it down no matter how many classrooms we have in our program or in the school to roughly 4 or 5 lines of code. Would that interest you? Meaning, if I could take this program, no matter how many classrooms I have, and reduce it down to 5, 6, 7, 8 lines of code and a couple of lines to display, about 10 lines of code versus potentially 400 or 800 lines of code, would that interest you? 10 lines of code to 800 lines of code. Well, that's what we're going to get into. That's what we need to understand. How do we do this? The concept is an array. Why are we learning this? Because you can write programs like this without ever using an array. But now what we want to teach you is how to utilize tools that are available to you as a programmer to make your programming a lot easier. Okay? Is it hard? There's nothing hard about it. But once again, it's different, and you got to understand the concepts. A little secret, I kind of primed you a little bit already with string manipulation. And so in our next video, we'll talk about and introduce you to arrays. All right, see you in the next video.